Hello everyone, welcome back. In this lecture, I am going to elaborate the construction of K-map. K-map is very important term which you might be familiar with. But in this lecture, I am going to elaborate each and everything about K-map, how the K-map can be constructed, what are the things which we need to take care about K-map, and why it is important. So let's start the construction of K-map. The K-map is known as Karnaugh map. K-map, you can say it is one of the modified form of truth table. So let's try to understand it with the help of a truth table. Okay. So let's say I'm taking three variables A, B, and C, and here's the output, let's say Y, or any function. So there'll be 8 combinations: 0, 0, 0, 0, 1, 1, 1, 1, right? Here we can write 0, 0, 1, 1, 0, 0, 1, 1, 0, 1, 0, 1, 0, 1, 0, 1, so right? Now the values which can be filled here, that can be either 0 or 1, right? Sometimes in a function, a position out of these 8 may be the don't care position. So possibly these places can be filled out by 3 values, either 0 or 1 or don't care. So I'm writing here 0, either we can fill, or we can fill 1, or we can fill don't care like X. So these 3 values can be filled out here, right? What is don't care? The don't care situation is if any of the combination does not affect the ultimate behavior of the function, that position we can set as don't care. So later on we will see when we solve the problems on K-map. Now let's say these positions are there. So as I told you, K-map is the modified form of truth table. There are 8 positions in this, and these terms we already have seen in the previous lecture. So this, let's say it is M0, this is min term 1, this is M2, this is M3, this is M4, this is M5, this is M6, and this is M7. Now if you look at the combination in min term, this 0 is representing, let's say, A bar, B is representing B bar, and this 0 is representing C bar, right? So in that way we are having these places. So if you consider there are places which we need to fill, there are 8 places which we are having. So M0, M1, M2, as we have written here, and these places can be filled out by either 0, 1 or X. Okay, M3, M4, M5, M6, and let's say M7. All these 8 places can be filled out by either 0, or 1 or don't care. Now when we construct the K-map, we can construct the K-map for 2 variables or 3 variables or 4 variables or any other number of variables. Why we construct the K-map? Because when we use Boolean algebra to simplify a function, there are multiple rules and there is no fixed way how one can simplify a given function, right? So the same function can be simplified by n number of ways and the ultimate simplified form may vary. And in terms of when we solve multiple choice questions in competitive exams, Boolean algebra may take more time as compared to the K-map. So most preferably we use K-map. Now let's see how do we construct the K-map. So if we arrange uh, these 8 cells, what we exactly do, we try to construct the K-map by following the adjacency rule. So what is the adjacency rule? These cells or whatever the possible cells are there. Now we are having 8 cells. If we have 4 variables, there will be 16 cells. If we are having 2 variables, there will be 4 cells, right? So all the possible cells we will arrange in such a manner so that any two adjacent cell should not be differ by more than 1 bit. Try to understand it. Let's say there are 3 variables. So one variable we need to consider as MSB, most significant bit, and one variable we need to consider as LSB, right? So let's say A is representing MSB, most significant bit, and C is representing LSB, least significant bit. Now when we represent this, and this is let's say 0, so I'm writing here A this side, and let's say this side I'm representing B and C. Okay, so if I'm saying this is M0, that means A bar, B bar, C bar it will represent, right? So I'm writing it, this is M0. Now what can be the adjacent of M0 which is differed by only 1 bit? So if I am considering M1, M1 is just having 1 bit difference as compared to M0. So M1 can be the adjacent cell of M0. So M0 is representing A is 0 and B is 0, C is 0. But M1 is representing A is 0, but B is 0 and C is 1, right? Now decide, can M2 be the adjacent of M1? If we do consider M1 and M2, this 0 is not varying, but this 0 is converting into 1 and this 1 is converting into 0. So there are 2 bit, those are changing. So that means M1 cannot be the adjacent of M2 in K-map. If we compare M1 with M3, so M1 is having 0, 0, 1 and M3 is having 0, 1, 1. That means this 0 is being converted into 1. So there is a 1 bit difference. So that means M3 can be the adjacent cell of this M1, right? Because it is having A value as 0. So this is representing A 0. And because this is 0, 1, so if we make it 1, 1 like this, only this bit is differing, right? This is same. Earlier it was 1 and now it is also 1. Now if you compare M3 and M2, so if you compare M3 and M2, there is only 1 bit difference. So M2 can be the adjacent cell of M3, right? So this is representing M2 and M2 is 1, 0, 1, 0. So B is 1 and C is 0, that means B and C bar it is representing, right? So now if A0 is clear to you, now A will be 1. When A will be 1, these 4 combinations again we can repeat. right? So here we can have, after, if both are 0 and this is 1, that means it is 4. So this will be M4, because it is representing 1 0 0. 1 0 0 means fourth term. So this is M4, right? Now after M4, can we have M5? So let's check M4 and M5. It is differing by 1 bit only. So that means M5 can be the adjacent to M4 in K-map. Now let's check M5 and M6. M5 is having 101 and M6 is having 110. So these two bits are differing. That means M6 cannot be the adjacent cell to M5 cell, right? So if you check M5 and M7, M5 and M7 is having only 1 bit difference. So M7 can be the adjacent of M5, right? And M6 will come here. So this will be the arrangement of the K map for 3 variables, right? I hope you're getting it right. So if we represent it in terms of, so you can say this is representing A bar and this is representing A. Here it is representing B bar, C bar. This is representing B bar C. This is BC and this is representing BC bar, right? So this is the K map and the arrangement. If there will be 4 variables, then again we will follow the similar condition of adjacency. Now in K map, if you see any of the cells, these two cells are adjacent because they are differing by 1 bit. These two cells are adjacent because they are differing by 1 bit. These two cells are adjacent, and so on, right? But if you compare these things like M0 and M2, so there is a cyclic property. This and this value, these two cells are also differing by 1 bit. Similarly, M4 and M6 must be differing by 1 bit. So M4 is here, it is 0 1 1 0 0, and M6 is here 1 1 0. If you compare, only this bit is changing here. So this and this we also consider as adjacent. So in case we need to make pairs, we can form the pairs of M0 and M2 and M4 and M6 and so on, right? So I hope you are understanding it. Now if you draw the K map for 2 variables, so this was for the 3 variables. There's another way to construct the K map for 3 variables. You can take 2 variables this side and 1 variable that side. So if you do so, like if you are taking A and B this side and let's say C that side, so how the K map will look like, let's try to draw it for 3 variable K map. Okay, so in that case, here there will be 4 combinations and here there will be 2 combinations, right? Because there is only 1 variable, and in rows there will be 4 rows because there are 2 variables involved. The K map will look like this. Let's see it. So when you fill the values in this is start with A bar, B bar, and this is C bar. This will be C, right? Now this A bar, B bar will become, let's say, A bar B, then AB, then A B bar. Okay. So when in this way, if you see all the adjacent cells, whether in this horizontal way or vertically, they are just differing by 1 bit, right? So whatever the values of these cells are having, we start filling it. So whether you are constructing like this or this, it doesn't affect. The combinations or grouping of the places will be same, right? So let's say if I fill here the values, so if it is 0, if it is 1, this is 0, this is 0, this is 1, So 5, this is 1, this is 1, and let's say this is 0. So there are 8 positions, right? Now you know how to fill this key map, whether it is designed by this or something like this. So if the first place is 0, that means M0 is 0. So this place will be filled as 0. Here it is like 0, right? Now M1 is 1. So M1 will be filled as 1. In this case, the arrangement is this is let's say I'm writing here. This is M1, M0. This will give you M1. Now you check it. 0, 1, 0. It will give you 2. So this is M2. Right, and 0, 1, 1 will give you 3, so this is M3. Now this is 1, 1, 0. 1, 1, 0 is 6, so this is M6, and 1, 1, 1 it is M7. Now this is 1, 0, 0, so this is M4, and this is M5, right? So arrangement is like this, in this way, and here it is already reflected. So M1 is 1. So M1 is 1, then we can fill it here. If M2 and M3 are 0, so M2 is 0, M3 is 0. In this arrangement, M2 is 0 and M3 is 0. Now M4 is 1, so M4 is here in this arrangement, so M4 is 1 here. Here M4 is 1, so M4 is here, it is 1. Then M5 is 1, M6 is 1, then M7 is 0, so M5 is 1, M6 is 1, and M7 is 0. M5 is 1 here, M6 is 1 here, M7 is 0. So I hope you have understood how you can draw the K-map for 3 variables, right? Let's say if you want to draw the K-map for 2 variables, so 2 variables K-map. Okay. So how we can draw the K-map for 2 variables? 2 variables, it will have only 4 cells like this. So if there are 4 cells, the combinations of 2 variables, one variable, let's say A bar, then it will become A here. If it is B bar, then it will become B here. So this is the 0th position. This is 0, 1, so it is 1 position. It is 1, 0, so it is second, and this is third. It will look like this only. So there will be only 4 cells. You can draw it completely, right? In truth table, the combinations will be, you know that it is A bar, B bar, A bar, B, then A B bar, then A B. So these 4 combinations you will arrange. This will represent 0, this will represent 1, this will represent 2, and this will represent 3. Okay, so 0 and 2, you compare, like this is 0 and this is 2, it is differ by this bit only, 1 bit difference, right? Only A bar is converting into A, so there is only 1 bit difference. B bar is here and B bar is here, so these are adjacent. If you compare 0, 1, 0 and 1, they are differing by B bar and B only, so these are adjacent. Now if you compare 2, 3, 2, 3 are already, this is 2 and this is 3, they are differing by B bar and B only, right? 1, 3, if you compare, this is 1 and this is the third, so they are differing by A bar and A only, B is same. So this 2 variable K-map is also satisfying the same adjacency condition, right? Now if you try to draw the 3 variable K-map, so if you draw the 3 variable K-map, 3 variable we have already seen, draw the 4 variable K-map. 4 variable will have 16 different combinations in truth table. So in K-map also there will be 16 cells. So if you draw it, it will look like a bit lengthy one. So draw something like this. We need to draw 16 cells. Okay. Let's divide it something like this. Right. Now let's draw the 16 cells. It is, I think, more than 16. So okay, these are only 4 cross 4, right? 16 cells for 4 variable. We did not to divide it further. So the combinations, like you need to assume the variables. The variables, like if you are having A, B, C, D, so the combination will be A, B, C, D or bar. Then you have A bar, B bar, C bar, D, and so on. So they'll be having A bar, A bar, A, 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 A. You'll be having B, B, B bar, B bar, B, B, right? No, because there'll be so 8 A bar and then, right? Then the combination will goes like this. So it will be constructed like there'll be 8 times A bar and then 8 times A. So the combination, you know that I have already told you. Then A 4 times and there will be 4 times A more. Then we write 4 times B bar, then 4 times B, then 4 times B bar, then 4 times B, then 2 times C bar, 2 times C, 2 times C bar, and so on. So 16 combinations from M0 till we will get M15, right? Now we need to see the arrangement here. So let's say this is, I'm considering MSB, and D I'm considering as LSB, least significant bit. So CD this side I'm taking and AB this side I'm taking. Now the combination we can form in the same manner. So A bar B bar, then A bar B, then we will take AB, and then we will take A B bar, so that every adjacent cell will be differ by 1 bit only. Similarly, the same combination we can make here: C bar D bar, C bar D, then CD, then CD bar, right? So now if you talk in terms of the places, this is min term, which min term? So let's change the pen color, and this is min term 0 because all are 0. This will be M1, this is M2, this is M3, right? This is fine. Now after M2, if you find out, this is 0 1 0 0, so this is M4. 100 will give you 4, right? Then this is 0 1 0 1, so it is M5. 101 will be 5 only. Then this is M6 and this is M7, we know that. Now after M7, this is 100, so 8 will come here, M8, M9, and this will be min term 10, this will be min term 11. 12 will come here, so this is 1100, 12, M12, then min term 13, 14 and minterm 15. So this will be the arrangement of 4 cross 4 K map. Now let's consider if we are having 5 variables. So how we can construct the 5 variable K map? Now in case we are having 5 variable, there will be 32 combinations, 2 to the power 5. So it will give us 32 combinations, right? So let's say if I draw the K map, how it will look like. I have two choices, that if there are 5 variables, I can take 3 variables here like ABC this side, and let's say DE I can take this side, or I can take 2 variable here and 3 variable this side, right? So because number of variables are odd, we need to arrange. If we arrange like this third variable may create you confusion. So to make it easy, first make all the combinations of this BC along with A bar. So you have A bar, A bar, A bar, A bar 4 times, and then we will make the combinations of A with BC 4 times, right? So let me segregate it like this, will help you to understand. Now this B and C, there are 2 combinations we have, so it is B bar C bar, B bar C, then BC and BC bar. We have already seen, right? So there are only 2 variable D and E, no confusion should be there. D E bar, D bar E bar, right? Then it will be D bar E, then D E, and then D E bar. Now here also with A we will write same combination, so B bar C bar, B bar C, BC and BC bar. So this will represent the 5 variable K map. If you want to find out the positioning in this, or shell arrangement is also not very difficult to understand. Let me divide it into number of cells. So the very first row, writing like this, then the second row, let's say this, third row, and then fourth row, and so on. So we can arrange like this. Okay, now you write it. So this is min term 0. Oh, sorry, this is min term 0 because all A bar, B bar, C bar, D bar, E bar, right? This is 0 0 0 0 1, so it is min term 1. This is all 3 0 with 2 1, so this is min term 3. This is min term 4, right? Right. Then this is 0 0 1 0 0, so 1 0 0 will give us, oh, this is not 4, min term 2, right? M4 will come here because this is 4. And then this will be 0 0 1 0 1, so this is 5, then it is 6, then it is 7. It is fine. Now if you find out 0 1 1 0 0, 1 1 0 0 will give us 1 1 0 0 1 1 0 0, and this is also 0 will give us, this place gives us 2 to the power 0, this gives us 2 to the power 1, this gives us 2 to the power 2, and this gives us 2 to the power 3. So 8 plus 4, it will give us 12. So this is M12, right? Now if it is M12, then this will be 13, this is 14, and this is 15. Now this place is 0 1 0, here it is 0 0, right? So it is 8 actually. This is 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, that is 8. So M8 is here. If this is 8, this will be 9, right? This is 10, and this is 11. Now if you look at here, 1 0 0 0 0, so 1 0 0 0 0, this is 0 1 2 3 4, 2 to the power 4 is 16. So this is M16, right? So this M16, then it is 17, it is 18, and it is 19. It is 1 0 0 1 1. So 16 plus 3, it will be 19, right? Now if you look at here, this is 1 0 1 0 0, 1 0 1 0 0. So this is 16, and this is 4. 16 plus 4, 20, right? Right? So this is M20, this is M21, M22, and M23, right? Now this is 1 1 1 0 0. So 1 1 1 0 0, it is 16, 2 to the power 4, it is 8, it is 4. Now 16 plus 8 plus 4, it will give you 28. So this is M28, M29, M30, M31, right? Now this is 1 1 0 0 0. So 1 1 0 0 0 will give us 16 plus 8. 16 plus 8 is 24. M24, and this will be 25, and 26, M27. So this is the K-map for 5 variable, right? So this is sufficient for this lecture. In next class, we will talk about don't care conditions, and we will take few examples to minimize given Boolean functions with the help of K-map. Thank you.